Digital audio from Wikipedia, the free encyclopedia at en.wikipedia.org. Digital audio is technology that can be used to record, store, generate, manipulate, and reproduce sound using audio signals that have been encoded in digital form. Following significant advances in digital audio technology during the 1970s, it gradually replaced analog audio technology in many areas of sound production, sound recording, sound engineering, and telecommunications in the 1990s and 2000s. A microphone converts sound to an analog electrical signal. Then an analog to digital converter converts the analog signal into a digital signal. This digital signal can then be recorded, edited, and modified using digital audio tools. When the sound engineer wishes to listen to the recording on headphones or loudspeakers, or when a consumer wishes to listen to a digital sound file of a song, a digital to analog converter performs the reverse process, converting a digital signal back into an analog signal, which analog circuits amplify and send to a loudspeaker. Digital audio systems may include compression, storage, processing, and transmission components. Conversion to a digital format allows convenient manipulation, storage, transmission, and retrieval of an audio signal, unlike analog audio, in which making copies of a recording leads to degradation of the signal quality. When using digital audio, an infinite number of copies can be made without any degradation of the signal quality. Section 1. Overview. Digital audio technologies in the 2010s are used in the recording, manipulation, mass production, and distribution of sound, including recordings of songs, instrumental pieces, podcasts, sound effects, and other sounds. Modern online music distribution depends on digital recording and data compression. The availability of music as data files rather than as physical objects has significantly reduced the cost of distribution. Before digital audio, the music industry distributed and sold music by selling physical copies of albums in the form of records, tapes, and then CDs. With digital audio and online distribution systems such as iTunes, companies sell digital sound files to consumers, which the consumer receives over the internet. This digital audio/internet distribution model is much less expensive than producing physical copies of recordings, packaging, and shipping them to stores. An analog audio system captures sound and converts their physical waveforms into electrical representations of those waveforms by use of a transducer, such as a microphone. The sounds are then stored as on tape or transmitted. The process is reversed for playback. The audio signal is amplified and then converted back into physical waveforms via a loudspeaker. Analog audio retains its fundamental wave-like characteristics throughout its storage, transformation, duplication, and amplification. Analog audio signals are susceptible to noise and distortion due to the innate characteristics of electronic circuits and associated devices. Disturbances in a digital system do not result in error unless the disturbance is so large as to result in a symbol being misinterpreted as another symbol, or disturb the sequence of symbols. It is therefore generally possible to have an entirely error-free digital audio system in which no noise or distortion is introduced between conversion to digital format and conversion back to analog. A digital audio signal may be encoded for correction of any errors that might occur in the storage or transmission of the signal, but this is not strictly part of the digital audio process. This technique, known as channel coding, is essential for broadcast or recorded digital systems to maintain bit accuracy. The discrete time and level of the binary signal allow the decoder to recreate the analog signal upon replay. 8 to 14-bit modulation is a channel code used in audio compact disc, also known as CD. Section 1.1. Conversion process. A digital audio system starts with an ADC that converts an analog signal to a digital signal. The ADC runs at a specified sampling rate and converts at a known bit resolution. CD audio, for example, has a sampling rate of 44.1 kHz and a 16-bit resolution for each stereo channel. Analog signals that have not already been band limited must be passed through an anti-aliasing filter before conversion, to prevent the distortion that is caused by audio signals with frequencies higher than the Nyquist frequency, which is half the system's sampling rate. A digital audio signal may be stored or transmitted. Digital audio can be stored on a CD, a digital audio player, a hard drive, a USB flash drive, or any other digital storage device. The digital signal may then be altered through digital signal processing, where it may be filtered or have effects applied. Audio data compression techniques such as MP3, advanced audio coding, OGG Vorbis, or FLAC are commonly employed to reduce the file size. Digital audio can be streamed to other devices. For playback, digital audio must be converted back to an analog signal with a DAC. DACs run at a specific sampling rate and bit resolution, but may use oversampling, upsampling, or downsampling to convert signals that have been encoded with a different sampling rate. Section 2. History in commercial recording. Pulse code modulation was invented by British scientist Alec Reeves in 1937 and was used in telecommunications applications long before its first use in commercial broadcast and recording. Commercial digital recording was pioneered in Japan by NHK and Nippon Columbia, also known as Denon, in the 1960s. The first commercial digital recordings were released in 1971. The BBC also began to experiment with digital audio in the 1960s. By the early 1970s, it had developed a two-channel recorder, and in 1972 it deployed a digital audio transmission system that linked their broadcast center to the remote transmitters. The first 16-bit PCM recording in the United States was made by Thomas Stockham at the Santa Fe Opera in 1976 on a SoundStream recorder. An improved version of the SoundStream system was used to produce several classical recordings by Telarc in 1978. The 3M digital multi-track recorder in development at the time was based on BBC technology. The first all-digital album recorded on this machine was by Rye Coder's Bop Till You Drop in 1979. British recording label Decca began development of its own two-track digital audio recorders in 1978 and released the first European digital recording in 1979. Popular digital multi-track recorders produced by Sony and Mitsubishi in the early 1980s helped to bring about digital recording's acceptance by the major record companies. The 1982 introduction of the CD popularized digital audio with consumers. This sound file and all text in the article are licensed under the Creative Commons Attribution Share Alike 3.0 Unported License, available at creativecommons.org/licenses/by-sa/3.0.